This demo is about the basic motion of JetBot based on Jetson Orin Nano. Initially, we need to import the required libraries for this demo, including NVIDIA JetBot library and class robot, which has all the methods required to control the movement of our JetBot, and import the widgets library, which is used to graphically interface in our notebook. After we run this one, here we are creating a robot object from our robot class, and the robot object in general has different methods that we can use to control the JetBot. For example, we have robot.left with a speed 0.7, which will rotate our robot to the left at 70% of its maximum speed. You notice that when I run this method, the robot does not move because the robot itself, it has a supply. We need to turn on the supply for the motor driver. This is the battery from the bottom. We have to make it on. So it's rotated at a speed of 0.7. And method robot.stop will stop our robot. And we could use time delay to move our JetBot robot for a specific period of time and then stop it. And we could try this one and see here that the robot is rotating and stop by itself after 2 seconds. And we could change this period like to 1 second and see. It's rotate for 1 second and stop. And there are other methods like set motor, which control the speed of the two wheels. If we make both them 0.7, we expect our JetBot to move straight, as you can see, for 1 second. Another way to control the robot is directly setting the motor values, such as robot.left motor.value or robot.right underscore motor.value. Let's see. Another way to make it more interactive, we could control our JetBot by using the widgets, which provide more interactive interface. For example, here we are creating slider for the left and right motors, each with the values of minimum -1 and maximum of 1. Initially, these sliders, you can see, are displayed but have no effect until it's being linked to the robot. And the link can be done using the traitlets libraries, which connect widgets value with the robot motor values. So let's link it. And after linking, you can see that if we increase the right motor speed, our robot will rotate to the left side. And if we increase the left motor speed, it rotates to the right. If we increase both equally, moves forward. And we could also reverse both values to make robot to move backwards. Let's stop it. Or we could unlink the connection between the widgets and our robot. And now change in the sliders will no longer affect the motors. And here it's another way to control the JetBot by using buttons for different directions. See, you see here we have buttons for different directions, for forward, backward, left, right, and stop. For each button, we need to define what will happen if we press that button by assigning a function to it. Here we assign a function for the stop, for the step forward, and so on. For example, when the stop button is clicked, it runs one function, and when the forward button is pressed, it runs the another functions. We then link these functions to the buttons and test them. And this one here. As you can see, when we press the forward button, the JetBot moves forward. When we press backward, it moves backward, and left and right button accordingly. The last part is the heartbeat kill switch, which monitor the communication between our browser and the JetBot. Since they are connected wirelessly, if this communication is lost, we want the robot to stop automatically. For example, we can create a slider, this slider, to set the minimum time interval for receiving heartbeat signal. If the robot does not receive a signal within this time, it will stop. Let's try by first rotate our robot. Now our robot is rotating. Okay. So now we will reduce this heartbeat interval while the robot is rotating, and you will find that at a specific period of time it is stopped. Let's try it again. Our robot is rotating. Let's reduce it slowly. See, at 0.7 it lost the response. It takes more than 0.07 seconds. That's why it will stop the robot.